Today's lesson is 4.7 on standard form. Standard form is basically another way to write, another form as far as writing a linear equation. And it's ax plus by equals c, so that's the equation of the line. So there's a few rules that have to occur. A, b, and c all have to be integers, so that's rule number one. So that basically means no fractions, no decimals, they have to be integers. A second thing that has to occur, a and b are both not zero, so you either have to have either an x value or a y value, but you don't have to have both. And the third rule, a must be positive, so we can't have our first value with the x be a negative integer. One thing to point out, the b in standard form is not the same thing as what we did in slope-intercept form. So when we have this, and it's a lowercase b, that is different than our uppercase b in this. So they do not mean the same value. So we're going to rewrite the equations in standard form. So our first equation says y equals 5x minus 7. So our format needs to look like this. So we need to have our x and y's on the same side. So we're going to have to move our x in this equation. So we're going to subtract 5x from both sides. We end up with negative 7. We have negative 5x plus y equals negative 7. So when I look at all the rules that had to happen, one thing it said is that we had to have all integers, and we do. Negative 5, this would be like 1, and then negative 7, so they are all integers. We have both our x and y. So a and b are both available, and a must be positive. So the only thing we need to fix is this, because our a value is a negative. So the easiest way to do that and change negative 5x to positive 5x is to just make everything become its opposite sign. So since we have negative 5x, it's kind of like taking everything times negative 1. So this would now become 5x. This would be minus y. And the last one would be positive 7. So now our first term is a positive, and it doesn't matter on the next two because they can be negative or positive. Okay, the second one, we're going to have to do distributive property here first. So we have negative 3 times x is negative 3x, negative 3 times 3 is negative 9. And we're going to do the same thing we did on our first problem. We're going to get our x over on the left to start. So I'm going to add 3x to both sides. So we have 3x plus y minus 2 equals negative 9. Now the only thing I want on this side of my equation are my x and y values. So I need to get rid of that 2, and I'm going to add 2 to both sides. So just join that up with what's on my right side. 3x plus y would equal negative 7. And that completes that. We have a positive here in the place of a. Everything is an integer. We don't have any fractions or decimals, and we have both our x and y values. Remember, we have to have at least one. So this third problem, we have fractions, and we know in the end that we can't have fractions. Everything has to be an integer. So let's go ahead and get rid of those first. So if I have a 3 and a 2 here, I think about, well, what's my least common multiple for 3 and 2? That would be 6. So I'm going to take every single value times 6. So if I take 6 times y, I get 6y. If I take 2/3 times 6, I'm going to write that up here so you can look at that. That makes 12 over 3, which is really 4x. And really, half of 6 is 3. So we can just put plus 3. Now I just need to get my x over on the left. So I'm going to subtract that and take it over to the left. And we're going to write our x value first. And we notice right away that it's negative. So to change that, we're just going to make everything its opposite. So we end up with positive 4x minus 6y. Oops, that's supposed to be equals, and that would have to change to a negative 3. And there you have your problem in standard form. So let's move on to this next page. This one looks very different. We're going to take each of these and we're going to create a standard form equation for this. But to do it, our best route to get there is to take what we know and put it in an equation where it'll work out for us well. So we're going to use point-slope form because we know a point and a slope. And remember, point-slope form looks like this. So we're going to plug any information that we can in. Our y1 says that y is -5. Remember, we always put that in as the opposite because that's like minus -5 or plus 5. Slope is -6. My x1 is 3, which we know is always going to be the opposite of what's there, so that's x minus 3. So the next thing we'll do is apply that distributive property. So we have y plus 5 will stay as is. Over here on the right, now we're going to have -6 times x, or -6x, and then -6 times -3, which would be plus 18. So I'm going to start moving my x value by adding it to both sides. So I now have 6x plus y plus 5 equals 18. So I'm pretty close to standard format. I just need to get rid of this 5. So we have 6x plus y is 13. So that's our equation now in standard form. The second one is similar, except for the fact we've got a fraction here. So let's plug it into our point-slope formula. Our y1 is 1, so that'll be the opposite, -1. Our slope is 3/4. And then we have x, opposite of -4 is plus 4. So we have y minus 1, and then I'm going to distribute our 3/4 to each of our values in the parentheses. So we have 3/4 x, and then 4/1 times 3/4 would be 12/4, which is just plus 3. So at this point, I would try to get rid of that denominator. So don't ever do that until you've done your distributive property first. So we're going to go ahead and take everything by 4 because that's our least common multiple. We only have one denominator. So we're going to take everything, every term times 4. Even the one at the fraction. Okay. So I have 4y right here. Minus 4 equals 3/4 times 4/1, which is going to be 3/1 or 3x. And then 3 times 4 would be plus 12. So I'm going to subtract that 3x from both sides. So I end up with -3x plus 4y minus 4 equals 12. And I'm going to add 4 to both sides to get that x and y by itself. So we have -3x plus 4y equals 16. And again, we can't have a as a negative, so we're going to make everything its opposite. So we have 3x now minus 4y equals -16. Make sure you apply it to every single term. Okay, and then this one in the green, I'm not going to actually do that one because all you need to do is to take this and find m. So you would start with this, 5 minus 6 all over -12 minus 8. So your slope is now -1 over -20 or 1/20. So now you have your slope, and then you can pick one of these points and call it x1, y1, and then throw in this for your slope. So then it works just like the previous two that we've done. Okay, this page is very different because the only thing we're doing is we're finding our x-intercept value and our y-intercept value. So our x-intercept is where it hits the x-axis, so that would be at -2, 0. And our y-intercept value would be 0 for x and 3 for y. On our second line, x-intercept right here would be 4, 0. So it's hitting the x-axis at 4. And this value for our y-intercept would be 0, 1, because it's hitting the y-axis at 1. All right, so when we have our equations in standard form, we can actually substitute in our places where our graph would hit the x or y axis. So I'm going to start off with a t-chart. And we're going to solve this equation where we have 0 in for x, and we're going to find y. Then we're going to solve it where we have 0 in for y and find x. So we're going to work this part right here first. We're going to put 0 in for x. Well, if we take 4 times 0, that's basically 0, so we can wipe that out. So if we solve the rest of this, y would equal 4. So my first point for my equation 4x plus 2y equals 8 is to graph it at 0, 4, which is where it's going to hit on the y-axis. So we're going to put a point right there. And then the next part of this, we're going to put 0 in for y. So I'm going to put 0 in for y. So I have 4x, 2 times 0 is 0, so we can wipe that out. So x is going to equal 2. So my other point I'm going to put on my x-intercept would be at where x is 2, y is 0. And now I have 2 points, so I can connect those together to create my line. So that's what graphing using x and y intercepts looks like. So on any of the equations up here, you could do the same thing just by putting in 0 for x and 0 for y. And then you find your 2 points and graph. All right, so this next page, you have to write an equation in standard form of the line that passes through the following points. So step 1, we're going to put this in point slope. So I'm going to find the slope first. So we have 4 minus -2 over -5 minus 5. So I end up with 6 over -10, which simplifies down to -3/5. So there's our slope. And we have to pick one of the points. Doesn't really matter which one you pick. I'm going to pick this one just because both things are positive and it makes it a little bit easier. And we're going to plug it in our point slope. So here's our x1, y1. So our y1 is 1, so we throw in the opposite -1. Our slope is -3/5. Then we're going to take x and do the opposite of x, so that's -5. And we're going to apply our distributive property. So we have -3/5 x, and -3/5 times -5 over 1 would be a +3. This is the point where I would get rid of our denominator of 5, so we're going to take everything times 5. So this produces 5(1). This would be -5, or excuse me, 5y. I think I said 5(1). Equals, the 5's will cancel out here, and you get -3x plus 15. So I'm going to add 3x to both sides, which will give me 3x. I'll get rid of it here. Plus 5y. And then I'm also going to add my 5 to the other side. So I get 20 over there. And I have a positive a. Everything is an integer. And we're good to go. Now there will be times you might end up with a slope of something like this. like that. So your slope then you would throw in would just be 0. So you might end up with some things that just end up y equal